All right, so let's look at the probability generating function. This one's nice and easy. So my g of t is going to be probability times t to the x power. So 2/5. And of course I could use my decimals as well. And 3/10. I don't know. So again, it's not infinite, or I could think of it as infinite with zeros for my other probabilities. But really I just think of it as taking on my x values, and this is just another way of showing a full distribution without a table. So let's come look at a binomial distribution. So in this case, I know that for a binomial distribution, my expansion is going to be that the probability that x equals x will be 4 choose x, and then 1/3 to the x power, 2/3 to the 4 minus x power. So remember, this is ways it can happen, probability of it happening, probability of it not happening. So then if I think of my g of t, well, I'm going to start with 4 choose 0, which is just 1, 1/3 to the 0, 2/3 to the 4th. And then that'll be t to the 0, which is, of course, just 1. And then I'll have 4 choose 1, which is 4, times 1/3 times 2/3 to the 3rd, t to the 1st, 1, 4, 6, and then back to 4, and lastly I have 1, and then that's going to be 1/3 to the 4th, t to the 4th. Well, of course, this is just a binomial expansion, so I could rewrite this as 2/3 plus 1/3 t to the 4th power. So if I see a generating function that looks like a binomial, well, then it comes from a binomial distribution. So this is kind of nice. There's a whole bunch of other probability generating functions. How handy would it be if these were given in your formula booklet? But of course they're not. So we can think about where these come from. Here is a typo, that needs to be an equal sign. And then in the next video, I'm going to come back and we'll talk about expected values and variances.